have to say one thing. In the previous video, I had explained the complex and simple reaction. There I made a mistake that while explaining, I told that the complex reaction will take place within a step or single step. That is wrong. Actually, I mentioned, however, I written in the concept that more than one step. Don't confuse with that. And one more thing I left out to say, simple reaction is also called as elementary reaction. Simple reaction is also called as elementary reaction. With this, we should go to the today's topic. And the today's topic, in the previous video, I had completed the rate of reaction and factors affecting rate of reactions. Today's video, we are going to study the molecularity of a reaction. Molecularity of a reaction. How could you define the molecularity of a reaction? The number of reacting species here may be like ions, atoms, or molecules. The number of reacting species taking part in an elementary reaction which must collide simultaneously in order to bring about a chemical reactions. This is how you can define the molecularity of a reaction. I can explain this with considering an example. Let us consider the example of decomposition of ammonium nitrate. Here is the chemical equation. Ammonium nitrate decomposes to form nitrogen and 2 molecules of water. So that the molecule involved in this reaction is 1. So this reaction is called unimolecular reaction. And another example of simultaneous collision between the two species, that is dissociation of hydrogen iodide. 2 molecules of hydrogen iodide dissociates to form hydrogen plus iodine. Here the molecules which are involved are 2 molecules of hydrogen iodide. So this is the example for bimolecular reaction. If this is 1 molecule of hydrogen iodide and this is another molecule of hydrogen iodide, both will collide simultaneously to form the products. So here the reaction takes place. This is how the definition says. Nothing, here you can consider the molecularity nothing but the number of molecules involved in the reaction. Based on that, we can classify the reaction as unimolecular, bimolecular, trimolecular as follows. This is enough to say, but they were asked for 2 marks. Define molecularity of a reaction in your examination. So you can write this definition. Then the next concept we are going to focus is the order of a reaction. Order of a reaction is an important concept because based on the order we have the derivations. So let us consider the definition for order of a reaction. Order of a reaction can be defined as the sum of powers of the concentration of the reactants in the rate law expression. The sum of the powers of the concentration of the reactants in the rate law expression is called the order of that chemical reaction. So, order of the reaction may be 0, 1, 2, 3, etc. Since I could explain this order of reaction considering the rate equation, rate equals to K of concentration of A to the power of X and concentration of B to the power of Y. Here the exponents X and Y, the summation of this X and Y gives the order of the reaction. X plus Y, which gives the order of the reaction. Here is the definition as it resembles the sum of powers of the concentration. The concentration power sum which gives the of the reactants, which gives the rate law of expression, that is termed as the order of a reaction. So that now we had completed the rate, molecularity and order of the reaction. The next thing we have to learn is the unit of rate constant. What is rate constant? Rate constant, here what we written in the rate equation, the constant, the symbol K, which represents the rate constant. And the unit for this rate constant varies from the order of the reaction. For first order reaction, second order reaction, third order reaction, the rate constant's unit will be varied. How it is going to vary, I am going to explain. In general, rate constant of a reaction can be given by considering this equation: dm cube whole to the power of n minus 1 mole to the power of 1 minus n and second inverse. If you give the numbers for zero order reaction, n will be 0, and for first order reaction n will be 1, as follows. The rate constant will be for zero order reaction, the unit of rate constant is mole per dm cube per second, and for first order reaction it will be second inverse, and for second order reaction it will be dm cube per mole per second, and for third order reaction it will be dm cube whole square mole inverse of 2 and second inverse. This is the rate constant for first order, zero order, first order, second order and third order reactions.